Hello friends, welcome to my channel. In today's session, I'm going to cover Docker versus Kubernetes. We'll see what is meant by Docker and how the Kubernetes internally works. So without get delay, let's get started. So first we need to understand what is Docker. So Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same way you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code, you can significantly reduce the delay between writing code and running it in production. Docker provides the ability to package and run an application in a loosely isolated environment called a container. The isolation and security lets you run many containers simultaneously on given host. Containers are lightweighted and contain everything needed to run the application, so you don't need to rely on what's installed on the host. You can share containers while you work and be sure that everyone you share with gets the same container that works in the same way. Okay, friend. In this definition, I'm going to add more few more points, right? So Docker, why we the Docker is came into the picture, right? So in our traditional way of development, what we used to do, we as a developer, I'm developing a Java application. So in my machine, I have all the required softwares like say I'm developing on Java application. So I've installed JDK 1.8 and I've implemented few classes which perform the action, and now that time to test the build, right? So what I'll do, I'll create a jar and hand it over to tester. So in tester machine, so tester will take the jar and is trying to validate the jar whether the functionality is working as expected or not. So now the scenario, the tester has 1.7 version installed in his machine. So due to that, the few functionalities not working as expected, right? So that's the reason. So this Docker will help us to create a Docker image which is contain all the dependency versions which we developed using our development phase. And the same thing will hand over to the tester so that he's also will get the similar dependency in his machine so that there is no gap in the dependency part. So the Docker will give us more benefits like it's a lightweighted and occupies less space. Applications run in isolation, secure, portable, and a short boot uptime. So you don't need to wait for time to validate the application. It will quickly boot up the application. So with a Docker container, application can work efficiently in a different computer environments, right? There are multiple benefits with the use of Docker. Let's see what is the Docker architecture. So here is the architecture diagram for Docker. So as the client, right, we used to do the pull, build, run, and start. So basically, all the instructions are given in the Docker file, which is going to be pulled to Docker. That is like the Docker machine. So basically, what it does, it will register in the Docker registry, right? So basically, it's a Docker hub will maintain all the registry here, and when the Docker daemon, it will help us to create the containers, right? When user do the instruction like want to build, and it will try to register in the Docker hub, and when user wants to run, it helps us to get the Docker and run the instant of it. So similar way, all these commands will flow through Docker daemon component. From here, it will try to get and create the container for us. So friends, I hope this is giving you a little more clear idea how the Docker works. So let's see how the Kubernetes works. So first, see what is Kubernetes. So Kubernetes is a portable, expandable open source platform for managing containerized workloads and services that facilitates both declarative and configuration and automation. It has a large, growing ecosystem. Kubernetes service support and tools are widely available. The name Kubernetes originated from Greek, meaning layman's or pilot. So K8s as an observation of results from counting the 8 letters between the K and the S. So the Google open sourced the Kubernetes project in 2014. So Kubernetes combines over 15 years of Google experience and running production workloads at scale with the best on-breed ideas and practices from the community. So friends, you understood, right? The Kubernetes is an open source platform for managing containerized workload and services. So basically, Kubernetes internally maintains the cluster. So the cluster has multiple nodes. So each node has multiple pods will be created. Each pod will contain a container. So let's discuss about more on the architecture of Kubernetes. So here if you could see when developer wants to create a Docker, he used to call an API server. So from here, it will make an entry to EC2D. If this is a key value pair, it will register the value. Uh, then it will return the message saying created successfully. But still the the pod will not get created because the scheduler every 5 seconds it will try to hit the API server and whether check if there any pod needs to be created or not. It will check if there any pod is that is need to be created. So it will retrieve the details from the E ETCD from here and it try to create. It will not create from here. Again, it will talk to controller and from controller again it will try to use the kubelet to perform this container creation. So it will create the part from inside the part. It will have the containers. Okay. Likewise, based on the replica, it will create that many pods inside the node. So there are two worker node here, and so once it is deployed, then the service will be visible for end user. Right, friends? I hope this is giving you some understanding. So basically, it's start with the ETCD. That is the component which trying to register first. So once it is adding the required thing, and then from using scheduler every 5 minutes, it will keep check. And if there any part needs to be registered, then controller will talk to API server. From here again, based on this, it will try to create the required Docker containers, right? Docker and with the and working nodes, right? So let's see what is going back in times. So just want to show the small differences. So which we started in our traditional deployment and what is the current container deployment? What is the difference and what is changed, right? See what is the differences like going back to the time, right? In our earlier traditional deployment, how we used to do that. Let's see. So here there are three stages. The traditional deployment, virtualized deployment and container deployment. Let's see for what each of this will explain, right? So when we talk about traditional deployment thing, as earlier on, organizations run application on physical servers. There were no way to define resources boundaries for application in a physical server. So, and this caused resource allocation issues. For example, if multiple applications run on a physical server, okay, there can be an instance where one application would take up most of the resources, and as a result, the other application would underperform. So a solution for this would be to run each application on a different physical server. So, but this did not scale as resources were underutilized, and it was expensive for organization to maintain many physical servers. Okay, friends, this you understood, right? So let's see what is visualized deployment. As a solution, visualization was introduced. It allows you to run multiple virtual machines on a single physical server's CPU. Virtualization allows application to be isolated between VMs and provide a level of security as the information of one application can't be freely accessible by another application. So virtualization allows better utilization of resource in a physical server and allows better scalability because an application can be added, updated easily, but reduce hardware cost and much more. With visualization, you can present a set of physical resources as a cluster of deposable virtual machines, right? So each VM is a full machine running all the components, including its own operating system on top of virtual virtualized hardware. So, so what it means, right? In which visualized deployment, or what it used to do, it used to create a separate machines, right? So separate virtual machines for each what kind of scalability, correct? So the hypervisor it will try to create take an image of the OS and it will try to create all the required dependency and I mean OS and bin library and application. So this will take more data like file will be the huge and it is it's a kind of a GP size of uh, image that needs to be shared in the VM and so it will take more time to boot up also. So then later point, the container deployment came into, I mean, now that is more familiar, I mean, trend in the current deployment process, right? So containers are similar to VMs, but they have a relaxed isolation property to share the operating system among the application. Therefore, containers are considered lightweight, similar to VM. A container has its own file system share of CPU, memory, process, and more. As they are decoupled from the underlying infrastructure, they are portable across cloud and operating distribution. So in the container system, like container deployment, what it does, it will not create a separate OS for each container. So what it does, it will try to make use of the same OS kernel and it will try to create a container instead of VM virtual machine. It will try to create a container so that you can save a lot of resources with the doing this container approach, right, friends? And this is easy to maintain also scalability also. It's faster and even boot up also very fast. Okay, friends. And so what is the difference? Just I'm going to give you some simple differences between these two, the Docker and Kubernetes. The Docker, the first difference is Docker is the tool to deploy the containers. So, but whereas the Kubernetes is a container authorization tool, and whereas it contains different worker nodes actually. So, and also each worker node it will maintain a different pod, and inside the pod the containers will be present, right? So the second point is right, Docker runs on a single node, right? But in the Docker it is a single node, but whereas in the Kubernetes there will be a multiple worker node that is come under cluster, right? Across a cluster, multiple worker nodes. And in Docker, communication between two different nodes is not possible because they are totally different ports. And here in the Kubernetes, all the same node the containers can be communicate because the node is giving the abstraction for the nodes so that it is in the same namespace so that communication can be possible. And the Fourth point, like Docker Swarm is used to managing containers, which comes with the enterprise edition, not preferred by most company. But whereas Kubernetes is an open source platform also, this is widely used in industries. And the last point, Docker's automatically scaling and failover for your application running on the container not possible. So whereas Kubernetes take care of scaling and failover for your application running on the container. So I hope this session is give some basic idea about Docker and Kubernetes. So in upcoming session, I'll try to give some demo on this topic. Until then, thanks. Bye. Thanks for watching. I hope you enjoyed this video. If you did, please be sure to hit the thumbs up button and subscribe to my channel for more great content. I post new videos every frequent, so you don't want to miss out. Thank you.